page 88. The arm of a crane makes a 40-degree angle with the horizontal. If the arm is 20 meters long, how high is the end of the arm above the ground? And the ground is the horizontal. So we know theta is 40 degrees. We know hypotenuse is 20 meters. And we want to know opposite. So we're looking for the ratio that uses H and O, and that's sine. So the sine of 40 is equal to opposite, which we don't know. I'm going to call that H for height, over hypotenuse, which is 20. So we're going to move that 20. Cancel it there. So the height is going to be 20 times the sine of 40. And you will need your calculator to do that. And I didn't set you a rounding rule. Let's do to the tenths on this one. So round to tenths. I like 12.9 meters for that height. And that's reasonable for a crane to lift something 12.9 meters. An airplane is flying at an altitude, that's a straight line distance of 10,000 meters, and makes an angle of 15 degrees with the ground. What is the horizontal distance covered by the airplane? So we're looking for the ground distance, not the hypotenuse, not the line of sight. So we want to know adjacent. We do know opposite. So we need a ratio that puts O and A together, and we know theta is 15 degrees. So this is TOA. Tangent of 15 equals opposite over adjacent. And I tell you what, I'm going to use G for ground. Okay, so we don't know G. We're going to have to do a little work here. Cancel it out. And then we need to move tan 15, so that's getting divided out of there. And that leaves me with G on this side. So G is 10,000 divided by tan 15, rounded to the 10th. This would be about 34,320.5 feet. And I don't think that's going to be meters. I think I didn't make this problem up, but I believe we need to change that to feet, or this problem wouldn't be realistic. So let's make that become, and I'm being nitpicky here, but let's make it feet. And that way our plane is a little more in line with reality. Okay, a football field has a 3-degree slope. And remember, these are not to scale. I know that's more than 3 degrees. It's just a figure to look at. If a player is running up the slope for 50 meters, how much higher is the player than where they started? Boy, the grammar in that is not very good, is it? So we want to know the height of the player from where he or she started. So here's the base, the ground. The football field slopes up just a little bit. 3 degrees is not a lot. It is our theta. We want to know opposite. That's our question mark. We know hypotenuse. That's the slope. So we want the one that does H and O, and that's so. It's sine. The sine of 3 degrees is equal to the opposite, which we don't know, over hypotenuse, which we do know. And we're going to multiply both sides by 50. And so the height is going to be 50 times the sine of 3. And that's about 2.6 meters. Remember, we're talking about a human being running. So 2.6 meters is a pretty good answer. If it were 260 with a 3-degree angle, I would be leery. But this is reasonable for that question. A 50-meter tall building casts a shadow that makes a 30-degree angle with the ground. How tall is the shadow? I would say how wide or how long is the shadow, but we're looking for the shadow. So we know theta. We don't care about hypotenuse this time. We know opposite. And we want to know adjacent. So we have O and A, and that's TOA. So tangent of 30 is equal to opposite over adjacent. I'm going to call that S for shadow. So in order to cancel that S, we have to multiply it to both sides. So I'm going to have to divide tan 30 to get it out of there, or work it out of there. So the shadow is approximately 50 divided by the tangent of 30, and I'm getting 86.6 meters. For the shadow of a 50-meter building, that's reasonable.